Okay, so this is a short video that looks at mind maps and concept maps. Hopefully gives like some sort of explanation of what they are, but also why they're a good thing to do, and also is going to sort of show that they can be useful across different key stages. So key stage 3, 4, and 5. So the mind maps, concept maps, those terms are sort of used interchangeably. I personally tend to use mind maps, and that's probably how I'm going to refer to it from now on. But equally, people also refer to them as concept maps. So just be aware if somebody asks you for a concept map, then they're asking for a mind map, and vice versa. So why bother with them? Well, they are actually a brilliant way of sort of organizing and learning information. They sort of force you to sort of process your understanding. They're also a very sort of visible way of demonstrating your understanding. So they can help you break down complex information. They can help you memorize it, although I think it's more about understanding than memorizing. And part of that is about seeing connections between different ideas. So we can all do a flashcard and learn a fact, but how does that fact fit together with another fact? And in a sense, that's sort of one of the downsides sometimes with things like flashcards. They're just literally memorizing a particular thing. Whereas mind maps allow you to try and put all of those individual things together and see how they all interconnect. They are difficult to do well, and a lot of people sort of misunderstand what a good mind map is. And some people also think that a spider diagram is a mind map. Now, if you're not sure what a spider diagram is, that is where you would have, some central concept. And then they would probably have like a circle around it. And then it would just be like a brainstorm almost. And they would have something like different things connected, But the thing is, all they are is they're just things that come off the concept. What they don't do is link those ideas together in any way. So that is a spider diagram, and we most definitely do not want to do a spider diagram, because really it's just like brainstorming. So please bear that in mind. Also just want to sort of be aware that, because they are difficult to do, they can take a few drafts. So I want you to think of mind maps as being like an organic process. So you might spend a bit of time on making one. You might accomplish it. You might end up with a mind map that you think, great, that's fantastic. That does all the things I hoped it was going to do. But also bear in mind that it may be that in the future that you might want to come back to that mind map and modify it, improve it. You might learn new things. You might understand different connections. And so I want you to think of it as a mind map as being sort of an organic thing, an organic tool, which you can sort of constantly improve on. So I'm going to show you some examples during this video of some mind maps that I've done. And I can tell you now that the ones that you're going to see have evolved over time, and they are very likely to continue evolving over time. So they're not, whilst they have a sort of a certain finished aspect to them, they're most definitely going to be improved and extended and over time. So this is a really nice sort of diagram that explains a concept by using a concept map. I have to apologize for the low resolution. Unfortunately, this is the highest, sort of the best quality version of this that I could find. But it does sort of explain the concept map, the idea of a concept map pretty well. So at the center, we've got what is it that fundamentally that this is about? This is fundamentally about the concept map, right? And so in a concept map, what we might be looking at considering is sort of the major ideas that make up whatever that concept is. And then once we've got those major ideas, we might connect them together to form a sort of a network. And that network would consist of keywords, would be a network of keywords. So that's why we can also say that a concept map consists of keywords. It says about being in boxes. I'm not. I wouldn't be wedded necessarily to that. I think maybe it can make things a little clearer, but at the same time, I'm not going to highlight the boxes bit. But what we do with those keywords, and the way that we show that how these ideas are connected, is we might connect them using linking phrases. Again, that isn't absolutely well. You'll see some examples. They can, and the amount of how much you link using phrases can vary a little bit. You're almost certainly going to use arrows rather than just lines. Arrows are quite useful because they obviously show you're moving from one thing to another. Going back, so a concept map is therefore, it can represent the relationships, and those relationships are between concepts and ideas, and we can show how they're connected. All right. And in a sense, the arrows that we referred to, they are a way of defining those relationships to an extent. Okay. And they're useful as not just as a learning tool, because they help you sort of reflect on your learning. Okay, so they make you think about your understanding. They make you appreciate what you know, and probably what you don't know. And that then in part, but the second part might be more to do with the fact that you're aware that something should be a feature of a concept map of a particular topic, but you're not really sure how that does connect with other ideas or with other keywords or whatever, or you're not really sure what relationship it has with other things. So, and to improve your understanding of something, you have to sort of be able to confront those difficulties. If you're not aware of them, you can't really get better at them. And one of the things that a concept map does is help you become aware of the areas that perhaps you're not quite so confident on, and you don't quite understand as well. Okay, so this page is showing a sort of series of steps that you could follow to try and help you sort of arrive or produce your mind map. I'm sorry it's quite a lot of text on a single page. I ummed and ahed about whether I should break it up, but I decided that actually it was better on the whole to have all of them just listed on one slide. So you can always pause the video and just take your time to read through them. But obviously, where were you going to start? Well, you're going to start with, well, what is it you want to do a mind map of? So what's the topic, or what's the sort of core concept? So if you've been doing a particular topic in school, like say sound, or you've been doing a topic like forces or whatever it is, then that is your main topic, and that's what you want your mind map to cover. And then it's got something here about brainstorming everything you already know about the topic. So you want to sort of a piece of paper at the side, and you want to just try and list all the things that you feel you already know. And already what that's doing is that's forcing you to think carefully and hard about that topic and try and sort of remember and recover all of the things that you feel are relevant to that. And then organise the information by major ideas or points. Can you sort of begin to group them together? I wouldn't, it's not that they have to be perfectly grouped, but maybe you can begin to see that, oh yeah, that those collect together and those collect together, and so on and so on. And then this is also quite important in relation to 2. So the reviewing the course materials and vocabulary. So the brainstorming was you trying to remember everything, was you trying to recover everything, but you might have missed things. And rather than you, so the reviewing the course materials is is you going back through your notes, or going back through, or looking at a revision guide or something, or both of those things in fact, and seeing anything that you've missed basically when you brainstormed. And it's better to do the brainstorm first rather than just jump to looking at those course materials, because that brainstorming is already going to have started you thinking about it, the topic, and already started you thinking about how you might be able to link things together, and it's already increased your sort of ability to remember these things. So then you can begin to place the information on a diagram or map. So different people, if you look on the internet, you'll see different sort of suggestions, and there isn't like one perfect way. I personally like to put my concept in the middle, or I might have it in the middle but slightly up. Some people put it actually as a title at the top, and they see it as a much more hierarchical thing, so it's going downwards all the time. But I prefer to see it sort of maybe in the middle or slightly up from the middle. And also bear in mind that you are no way are you going to get this correct and beautiful and whatever at the first time round. So just, you're going to do it very roughly to begin with. Just use a pencil. And don't agonize too much about it, about perfection at the start. You can tidy it up once you've got a pretty good idea of how things connect together. So you've got your central concept, and you want to try and think, well, what major sort of points can you lead directly from that? Well, we'll look at some examples from later, but I don't know, maybe with sound, it could have been that central concept is waves, and that could have been something that we might have had coming directly away from sound. It could have been about energy transfer. That could have been one as well. Anyway, there are various things that we could think about. Then you want to try and sort of, once you've got a few ideas down, see can you begin to link them. Sometimes you write something down, it prompts a thought, a new idea, which is great. It's got here label connecting strands of words or phrases. Use arrows, always use arrows. Other symbols, the other symbols is entirely up to you, but you might draw little pictures sometimes to describe the relationship. That helps sort of condense space and makes you think about the idea in a slightly different way. Make sure you're trying to include definitions if that's relevant, or formulae or equations if that's relevant, and explanations. And once you think you've got a very rough and ready, but you're beginning to get close to what you think is the bare bones of a concept map, or your mind map, even if you have to redraw it, you want to step back at that point, and maybe actually go away for a little bit and then come back. But anyway, you want to sort of critique your map. So do the ideas fit together? Have you noted all of the relevant relationships? Have you missed anything? Have you noted any exceptions, or have you noticed any rules or whatever? This thing about what's the muddiest point. So is there a part of your mind map that you think, that's really work, it doesn't really fit together, or I haven't really explained it? Then you sort of think about what you can do to clarify it. And then just basically keep revising your mind map. Probably you want it to be fairly finished at one point, maybe that you're doing it and at the end of a topic, and you want it, and you've got a test coming up or something, so you want it fairly finished by that point. But beyond that, that topic's probably going to feature again at some point in your education. So file it and sometimes come back to it and see what improvements you might be able to make. Maybe you do another topic that gives you some ideas to the one that you did a mind map on. So again, think of this not as a permanent sort of artifact, but something that you can modify over time. So we've got a sort of semi-finished one here. It's quite sort of basic, it's quite simple, but it is going to allow us to just sort of explore some of those things that we were looking at just now. So we've got elements. Elements is sort of near the center, so that sort of indicates that elements is one of the sort of focal points of this particular mind map. And we've got here that they are a type of chemical, and we've got another box that of the same height that's sort of linked to it. It says, there's something made of elements. I'm pretty sure that's going to be compounds, right? So we've got compounds in this box here. So this is really a mind map about elements and compounds. So if we look at what the arrow that goes down from compounds, so if we look at this arrow here, we can see that what is it saying is it says it contains more than one type of. So we know that compounds contain more than one type of atom. And so we've got our keywords here, like atom, like compounds, like elements. But now what we're doing, we've got the arrow going from compounds to atom, and we've got a sort of a linking phrase. Now we've got contains more than one type of atom when we go from compounds to atom. So for elements, one of the things that we know is that they are made up of only one type of atom. Okay. What else from elements? We've got an arrow coming away to a box, and it says each have a chemical. So one of the things that is like we learn very early on about elements is that they have a chemical symbol that represents that element. What else have we got going on? So elements can burn in, okay, and we've got a gap, and then we've got an arrow that goes oxides, and then an arrow back from oxides saying which always contain. So one of the things that we know that oxides always contain oxygen. That's what the oxide part of the name is. So we've got oxygen. So we know that elements can burn in oxygen and they form oxides. Okay, so burn in oxygen to form oxides. We know that if we're told that something is an oxide, that we know that it contains oxygen. And we know, and we've got a backwards arrow here, so we know that oxygen is an element. It says are both. That's a slight. I don't think there is a slight problem with this example, but it's because they're referring to the copper here. So they're saying copper and oxygen are both elements. All right. So what else have we got here? So if we follow this around, so we've got water and we've got carbon dioxide, and the arrow here is saying that they are both compounds, and we know that they're both compounds because they contain more than one type of atom. You see how these things are linking up. These are also examples of molecules, and if we have a molecule, if we know something is a molecule, then it's going to have a chemical formula, right? Molecules have chemical formula. I'll put formulae because it's molecules. And what chemical formulae show us is the types, the numbers and the types of atom. So if I asked you for the chemical formula of water, you'd say H2O, and that's telling you, that formula is telling you that there are 2 hydrogens and 1 oxygen. And if I asked you for carbon dioxide, you would say it was CO2. So that was 1 carbon and 1 oxygen. So there we go. We just got the sort of basics, the start of a mind map where we can begin to see how different sort of keywords and ideas in elements and compounds, how they can begin to fit together, and how we can make linking phrases, how we can show, we've got atom, but we've shown how atom is relevant to elements, and we've shown how atom is relevant to compounds. So that's just the beginning, sort of an idea of how we might go about putting together a mind map. So I'm just going to go through and show 3 mind maps that I've made. One is a Key Stage 3 mind map, one is Key Stage 4, one is Key Stage 5, to show that getting good at mind maps is a skill that can serve you all the way through your education. I mean, there's nothing to stop a mind map still being useful at university as well. Naturally, all of the ones I'm going to show are chemistry, just because those are the ones that I've done in the past. But really, a mind map can be used for any subject. If you were analysing or wanted to do a mind map about, say, King Lear by Shakespeare, you could have key themes like nature or religion or whatever, and then you can explore. You can have lines from that to say the characters or quotes or whatever. So there are ways of using this for a variety of subjects, but obviously I'm going to focus primarily on chemistry as it's mind maps of that subject that I've produced. Okay, so here's a Key Stage 3 mind map that I did. I don't want to go through the whole thing. You can always pause the video and take your time and look through it, but I guess I can just focus on a couple of things. So this was a topic that we called reactions and reactivity, and you can see that one of the things that I've done is I've highlighted reactions in yellow, and I have then got arrows to basically 3 types of reaction, or at least how we would refer to them at Key Stage 3. So there's a thermal decomposition reaction, there's an oxidation reaction, and displacement. I probably also really should have highlighted this bit yellow because I've got a neutralization reaction here, and neutralization would be another type of reaction. So, you know, I'm already beginning to spot things that I could perhaps tweak or improve. And then the other part, reactivity. So one of the things that we learned in this topic was that there was something called a reactivity series. And I probably should be linking an arrow down towards this because this is the reactivity series. What I've got here is sort of a way of just sort of a shortish hand way of remembering the order. So whilst it doesn't exactly say potassium ahead of above sodium, what it does make clear is that it's the group 1 elements that are most reactive, then group 2, then group 3, and then we have these things called the transition metals. So some of these would rely on your understanding of the periodic table and which parts of the periodic table we were referring to. So, you know, some of this might be slightly, not necessarily beyond key stage 3, but something which is at the sort of extended end of key stage 3. Here I've got this word exothermic, which on its own, it's not really explained here, but what we've got, if we go back to reactions, is that in a reaction there is always going to be a transfer of energy, and then that transfer of energy is either endothermic or exothermic. And you can see that the colour I've used there is the same as the colour I've got down in the bottom right hand corner. I'm not saying that's the most clearly obvious thing. I've also got it here when it's an oxidation reaction. I've got it here when it's about this changes in state. And so that's sort of making a link and actually thinking about it, what I should have done. So again, you see, as I'm reflecting and analysing my mind map, I'm spotting improvements. I haven't written either exothermic or endothermic for thermal decomposition, and I should write endothermic. Again, what do those words mean? Well, that's what our mind map tells us. So endothermic means that energy is taken in from the surroundings. Fine, that's like a definitional almost, really. But what does that mean to us in terms of our observations? Well, that means that the temperature is going to decrease, and then ditto with exothermic. Here, so we go down to displacement reactions. They involve metals. We've got an explanation of how the metal and the displacement come together. So a more reactive metal will displace a less reactive one. What do we mean by more reactive? Well, look, we've headed back to our reactivity series. Here's just an example. So to give a concrete example of our of a displacement reaction, I've also just taken this as an opportunity. It's not, you know, as an opportunity to show or to just mention the conservation of mass. So you know, I suppose one of the things to get away from this, or to get from this, is the fact the use of colour sometimes to make those links between types of ideas. So I've got the types of reactions in yellow. I've got, if it's exothermic, I've got it in highlighted in a sort of pinky red, and so on. And sometimes I've just used some other colour to just try and emphasise something. And here, the fact that we've got carbon dioxide highlighted in green is because it's the carbon dioxide that turns lime water cloudy, so that's like our test. So I already have realised there is various few things that I could improve on this, and that's fine. What's here is good. What's here could be better. But that's an example of a type of mind map that could be done for, say, a Key Stage 3 science topic. So we'll now look at a Key Stage 4 mind map. And the mind map I'm going to show is probably towards the end of the Key Stage 4 chemistry course, which includes combined science, so isn't just exclusively the single subject. It could be absolutely relevant to the combined science chemistry that's studied. And in this one, which I think actually is a much cleaner and nicer mind map compared to the previous one, the Key Stage 3 one, and I've probably spent longer. I've probably had more time where I've tweaked this one, but it isn't really so much as a concept that I have at the centre, so that it's not like I've picked a particular theme. And maybe that's one of the reasons this works so well, or maybe it's one of the reasons I like it so much. The way I started this mind map was simply with a chemical equation, a particular reaction. So I started with aluminium oxide becoming aluminium and oxygen. So, and I built from there. So one of the things that I did is I made sure I added the state symbols, and our state symbols reflect the structure and bonding that's present in these particular substances, and that's what then goes on to explore. So we recognize that oxygen's a gas. It's a simple molecule. And why is it a simple molecule? There are weak electrostatic forces of attraction between the molecules. That means there's a low boiling point, which means it's a gas. When we talk about it being a simple molecule, well, here we're drawing how we could represent that as in displayed formulae, which I should probably label as that as displayed formulae. Gets a little bit hard to read, but you would obviously be able to zoom in on the real PDF. But we've now got like a dot and cross diagram that displayed formulae represents. Look, oxygen is an example of a diatomic element, and there are a number of them you have to remember. So there's a connection, and so my way of remembering, or the way that I suggest as a way of remembering, is that any element ending in gen or as a halogen is a diatomic element. So there we've got them: hydrogen, nitrogen, oxygen, and then 4 halogens there. So there's quite a lot of sort of chemistry in that area already. This is a nice equation because we have 3 types of structure and bonding. So we had our simple molecule. Here we've got a metal. So it's a solid, it's a metal, and then we talk about why it's a solid at room temperature. There's a giant lattice. Look, we've got a drawing of the lattice. We're talking about why it's a lot of energy is needed to break it apart. Just making the point here why it would have a particularly high melting point, and so on. Aluminium oxide is an ionic compound, making the point here about white solid. I could explain the white a little bit more actually on reflection. Here, that's probably where I wrote lattice first, so I just make it clear that it's a regular repeating pattern. So look, that's an example of a lattice, and just making it clear that harks back to the particle model that you did in year 7. So making a connection here about these two. Explain the bonding. We'll talk about the bonding. This bit here actually is slightly beyond GCSE, but it's an appreciation of why we have a particularly high melting point. Recognizing that we've got those 2 types of ions. Because aluminium oxide becoming aluminium and oxygen is a particular part of the course in the electrolysis section, and it has its about being dissolved in cryolite and so on, and to lower the melting point and therefore reduce costs. So that's mentioned there. So that's very specific to this reaction. It gives me an opportunity to just show the conservation of mass. Gives me an opportunity to show a quantitative sort of chemistry calculation, I guess. Allows me to just emphasize the fact that we can, from the equation, we get molar ratios and they're what we use for our quantitative chemistry here. It's a decomposition reaction that we're showing. What does that mean? So explain what decomposition means. In real life, it's done by electrolysis. I don't quite exactly explain what electrolysis is actually, so that's something I could add. So that's the breaking apart of something using electricity, but I do look at how we can think of electrolysis as a redox reaction and what that really means. And we've already mentioned the ions down in the ionic, so there's sort of connections there. Why would we use electrolysis? Because it's higher than carbon in the reactivity series. And look, there's a little mini reactivity series. And if we think back to the key stage 3 displacement, we could, for anything below carbon, we could use carbon to displace the oxygen that was with the metal. But we can't do that for anything above carbon, and aluminium is in group 3, which is above carbon. And then yeah, just a little bit, just a sort of a slightly more extended extension, sort of a more an explanation of the reactivity series, I guess, that doesn't really feature in the Key Stage 3 content. So there is an awful lot of chemistry there. If we were thinking about the GCSE, we would have present here units 1, atomic structure in the periodic table. Not lots of that, but still some of it. We've certainly got structure and bonding. That's a big feature. So all this stuff here is structure and bonding. We've got some quantitative, okay, and we've got some chemical changes. So we've got quite a lot, and we've just got a very little bit here that's energy transfer. So it just reminds us also that you have to put energy in to split the aluminium oxide apart. But obviously, if that's endothermic, then the opposite reaction, aluminium reacting with oxygen, must be an exothermic one. In fact, actually, that's the reaction, one of the reactions, that took place in launching the space shuttle. So the space shuttle had these booster rockets on the side, and they were solid state. And it was a fine aluminium powder was the main fuel, and it had an oxidizing agent, powerful oxidizing agent. And essentially, when you see those big plumes of white gas, well, actually they're smoke, but anyway, see those big white plumes from the rocket engines as the shuttle is taking off, what that white clouds are aluminium oxide, okay, which is a white solid. It's actually a smoke, really. Okay, so that's like an example of a Key Stage 4. And again, I'm pretty happy with this one, but already I've noticed a couple of things that maybe I would add or improve. And now to Key Stage 5. So I guess what we might be seeing is slightly greater detail on each of these mind maps. So it's going to be harder still to see the different parts of the next mind map. It's something I would really have done on an A3 piece of paper. And we're seeing this on this small screen. But anyway, it still gives us an idea that this is a technique that can serve us well across, throughout our education, basically. So this is a mind map that summarizes the different organic chemistry mechanisms that we have to do for A-level. There aren't that many, actually, although this probably looks like quite a lot. So we've got, as our central concept, we've got mechanisms. I'm not going to talk massively about this one, but just to show how there are ones that are described as free radical, nucleophilic, and electrophilic, and look, they've all been given that blue, because they've been given that blue highlighting to sort of show the connection between them. Okay, look, there's a definition of a nucleophile, and then there's some examples. There's a definition of an electrophile and some examples, and there's a definition of free radical. So, there are certain things that are sort of common features to them. And then it's a bit more like a family tree, this, I guess. When we talk about nucleophilic reactions, they could be addition-elimination or addition or substitution. And then those particular reactions would feature in particular families of compounds. So it's sort of giving that, and then what we've got in each of them is sort of example mechanism. And so so that's that covers, plus it doesn't go into the absolute detail for every single mechanism. It basically gives you gives you a big picture view of the course and the mechanisms aspect of organic chemistry, and that is quite a significant chunk of the course. We've been able to somehow get that onto an A3 page. Again, this is something I'm almost certainly going to tweak and add to as time goes by. So I guess what I haven't said up to this point is that clearly you can see, I think, from these examples that I actually use my iPad, and I've got a software program called GoodNotes. And what it does allow me to do is that it's very useful is I can just get my ideas down, but it's very easy to move things around. It's very easy to highlight but then change the colour or unhighlight or whatever gives me a lot more flexibility than if I was just putting it down on paper. So, you know, there is that other side of things where technology can help, but there's nothing to stop me doing this from paper, really. So, if you want to spend longer looking at this particular mind map, then you can just pause the video. But otherwise, that's really what I wanted to say. And I hope you've come away from this seeing the value and benefit of doing mind maps and why it's worth practicing and getting better at them. Your first mind map is not going to be brilliant, but if you persevere, you will get better at it. And I know I can get better at it. And I know that these are not the very final finished products. And actually, I don't think they ever will be utterly final and finished. There'll always be things that I can tweak or add or take or refine. But yeah, all right. Thank you.